Assalamu alaikum wa rahmatullahi wa barakatuh. Dear girls and boys, in the last topic we have solved question number MCQs till question number 16. So now with the page 35 we will solve the question number 17. What is the purpose of the commutator in the DC electric motor? So the purpose of the commutator is nothing but to reverse the direction of the current in the coil every half turn. So the answer is C. The magnet near a coil of wire is attracted to the coil only when there is a current in the coil. This statement explains this force of attraction. So as the magnet near the coil will attract means whenever a current is passes through the coil, it generate a magnetic field. So the answer is C. The current in the coil of wire create a magnetic field same as the bar magnet. Okay. A simple DC electric motor is fitted with a coil that rotates in a magnetic field. The commutator connects the power supply to the. So what is the purpose of the commutator? To reverse the direction of the current in the coil every 180 rotation, means every half turn of the coil. Now question number 20. Which statement about the electromagnetic induction is correct? So which statement is correct? Electromagnetic induction is nothing but an EMF is said to be induced into the wire. So the effect occurs when a magnet is moved away from a nearby conductor. Why cannot it be D? The effect only occur when a magnet is only, he is saying only, no. The electromagnetic induction will be produced when the magnet is moved in and out, both the time. Okay. So here the correct statement is C. What is the advantage of transmitting electricity high voltage? So that it should waste less energy should be wasted. So if you are supplying the voltage at a high in the transmitting cable, so less energy will be wasted because the current will be reduced. The wire is placed in a strong magnetic field. When a current is passed through the wire, it moves upward as shown. The current is reverse. So before in this direction, the wire is moving upward. If we reverse the direction of the current, so what will happen? The direction of the movement of the wire will also reverse. So it will move in a downward direction, means using your Fleming left hand rule. Now the diagram shows a current carrying conductor in a magnetic field. Which arrow shows the direction of the force acting on the conductor? Which direction? Again using Fleming left hand rule. From the field line goes from north to the south and the current is coming out, so the force is upward. It means the answer is A here. The diagram shows a wire between the two magnetic poles. The wire is connected in a circuit with an ammeter. The wire is moved downward towards the bottom of the page. A current is induced in the wire. A current is said to be induced. A current is said to be produced. In which direction is the force on the wire caused by this current? Caused by this current. See, the wire is moved into the magnetic field down into the page. We will use our Fleming right hand rule. Okay, down into the page, it means the current is in this direction. But now he is asking, due to that current, a force again it is developed by the coil. So in which direction will the force will move? If the current is up, downward, and the magnetic field is not to the south, the force is in the upward direction, or we say towards the top of the page. Like the diagram shows a copper wire X1 connected to a resistor. The wire is moved in a magnetic field between the pole of magnet. There is an induced current in the wire from Y to X. Y to X. So again this is Fleming right hand rule. So we will take the magnetic field. The current is going Y to the X. So Y to the X is nothing but the current is coming in. Down. Okay, so the force is acting downward, so the answer will be D here. Now question number 26. A current carrying wire XY lies in the magnetic field between the pole of the U-shaped electromagnet. A force acts on the XY because of the magnetic field. Each of the following action is carried out separately. The current in the wire XY is reversed. so the force direction will also be reverse. If the magnetic field is reverse, the force direction will also be reverse. But if both the current and the magnetic field are reversed at the same time, the force will remain same. So how many of this action cause the direction of the force on the wire x to xy to be reversed? Only two, we can say two action can cause. Okay. The graph shows the voltage induced across a coil changes with the time at the coil spin in the magnetic field. Which graph shows what happened when the coil spin more quickly? Means if the speed of the coil is increases, so what happened? The frequency also increases. The frequency also increases. Now 28, a current carrying coil in a magnetic field experience a turning effect. How can the turning effect be increased? So as I said, by increasing the current, by increasing the number of turns of a coil, or by using a stronger magnet. So here the increasing the number of turns of a coil. Okay, this is the correct option. Next, a transformer has a 1200 turns on the primary coil and 400 turns on the secondary coil. The voltage of an output voltage is 9 volt is induced across the secondary coil. So here what is the input voltage of the transformer? So our formula is V2 by V1 is equal to N2 by N1. So when you solve this one by using the formula, so what are the primary number of turn, boys? Primary number of turn, what is the output voltage? Output voltage is 90 and the secondary number of turn is 400 and the primary number of turn is 1200 and V1 we need to find out. When we solve it by using this formula, so the answer will be C here. Now again, question number 30, the diagram shows a transformer. The input voltage is 240 and they have given the primary and the secondary number of turn. What is the output voltage? Again, we will use the formula V2 by V1, N2 by N1. So we need the V1 is 240, V2 we need to find out, N2 is 40 and N1 is 800. So when we simplify and when we get it, it is 12 volt. Power loss in the transmission cable are reduced by increasing the transmission voltage. What is the expression for this reduction? So that the current reduces, reducing thermal energy loss. So that's why the current is being decreased by increasing the voltage.